I'm back. Today we'll be focusing on ketones, aldehydes, alcohols. Alcohols are organic compounds in which a hydrogen atom of an aliphatic carbon is replaced with a hydroxyl group. Thus an alcohol molecule consists of two parts, one containing the alkyl group and the other containing hydroxyl group. Physical properties of alcohols. The boiling point of alcohols. Alcohols generally have higher boiling points in comparison to other hydrocarbons having equal molecular masses. The solubility of alcohols. Hydrogen bonds are formed between water and alcohol molecules which make alcohol soluble in water. The acidity of alcohols. Primary alcohols are generally more acidic than secondary and tertiary alcohols due to the presence of unshared electrons on the oxygen atom. Alcohols act as Bronsted bases too. Chemical properties of alcohols. Oxidation of alcohol. Alcohols undergo oxidation in the presence of an oxidizing agent to produce aldehydes and ketones which upon further oxidation give carboxylic acids. Dehydration of alcohol. Upon treatment with protic acids, alcohols undergo dehydration, removal of a molecule of water to form alkene. IUPAC nomenclature of naming alcohols. Alcohols are named by replacing the suffix "an" with "onyl. If there is more than one hydroxyl group, O, the suffix is expanded to include a prefix that indicates the number of hydroxyl groups present, anidiol, anetriol, etc. The following is list of some common primary alcohols based on the IUPAC naming system. Examples of alcohols. Uses of alcohols. 1. Used as an ingredient in alcoholic beverages e.g. wine and beer. 2. Used to produce methylated spirit meth. 3. Used as a fuel. 4. Used as a solvent. Aldehydes. Any of a class of organic compounds, in which a carbon atom shares a double bond with an oxygen atom. A single bond with a hydrogen atom. The double bond between carbon and oxygen is characteristic of all aldehydes and is known as the carbonyl group. Structures of aldehydes. At least one of the attached groups must be a hydrogen atom and must be double bond to oxygen atom. Use CHO to identify an aldehyde rather than COH, which might be confused with an alcohol. Nomenclature of aldehydes. There are two general ways of naming aldehydes. Common nomenclature, name them after the common name of the corresponding carboxylic acid. Ends in IC acid or aldehyde. Examples of aldehydes. Uses of aldehydes. Ketones. Ketones, also known as ketone bodies, are byproducts of the body breaking down fat for energy that occurs when carbohydrate intake is low. For a person with diabetes, ketones are often the result of prolonged high blood sugar and insulin deficiency. The cells burn fat instead of glucose, and ketones form in the blood and spill into the urine. Types of ketones. IUPAC nomenclature of naming ketones. Ketones are named by replacing the suffix "an" with "onone." If there is more than one carbonyl group, C equals O, the suffix is expanded to include a prefix that indicates the number of carbonyl groups present, anidione, anetrione, etc. Examples of ketones. Uses of ketones. Physical properties of aldehydes and ketones. Boiling points of aldehydes and ketones. The boiling point of aldehydes and ketones is higher than that of nonpolar compounds, hydrocarbons, but lower than those of corresponding alcohols and carboxylic acids, as aldehydes and ketones do not form H bonds within themselves. Solubility of aldehydes and ketones. The lower members, up to 4 carbons, of aldehydes and ketones are soluble in water due to H bonding. The higher members do not dissolve in water because the hydrocarbon part is larger and resists the formation of hydrogen bonds with water molecules. Chemical properties of aldehydes and ketones. Reactivity of aliphatic aldehydes and ketones. 1. Inductive effect. Alkyl groups are electron donating in nature, i.e., CHO plus I effect. Hence, the presence of alkyl groups attached to the carbonyl group increases the electron density on the carbonyl carbon, thereby decreases its reactivity towards nucleophilic addition reactions. Therefore, the order of reactivity is 2. Steric hindrance. The more the number and the size of the alkyl group, the more difficult for a nucleophile to attack due to steric hindrance crowding. Hence, the order of reactivity is 1. Reactivity of aromatic aldehydes and ketones. Aromatic aldehydes and ketones exhibit electron-donating resonance, which increases the electron density on the carbonyl carbon. Because of this reason, the carbonyl carbon becomes less electrophilic, and hence is less susceptible to nucleophilic attack. Thank you.